Welcome, GAC Algebra 3, to another podcast. Hope you're doing well, studying section 1.6 to 1.9. Hey, I want to apologize, start us off today. I was supposed to do it live today at around 5 or 6 o'clock. So complications came up with some Easter stuff today. And so because of that, unfortunately, I'm not going to be able to do it live. And so I know this is pre-recorded. However, I think that just because it's pre-recorded doesn't mean I'm not going to answer questions. If you do, let's say tonight you do have any questions, maybe it's really pressing, feel free. You could text me or email me, and I'll do the best I can to respond back to you. The reason why I wasn't able to do it is because I don't have about an hour block time there. And again, so I apologize for that with today being Easter. Now, with that being said, even though today is Easter, I am doing this on Sunday right after church and hoping that you're doing hopefully you're doing well there. So what we'll do today, just to kind of give you a heads up, I'm going to kind of start off by going over some things of how part 1 and part 2 are blocked off on the test. Then I'm going to go over some things that I'd focus on. We're going to hit on the review. By the way, the review is very nice compared to the test. Now, if you were in my Algebra 3 class, you'll notice that a lot of these problems are different. I did that on purpose. I used Miss Lawrence's review, and I think Miss Allen used the same review as well to be able to give you some different problems. So if you wanted to practice some new ones, you could do that as well. Also note that as tomorrow looks, you could come in tomorrow morning. I'm going to start the review session at 7 rather than 7:15. Noting that 7 I know is very early for y'all, but if you needed to come by and get some more help on that, you could come by at 7 and get help on that going forward. All right? All right, let's do this. As we transition, I'm going to change screens here. And what we're going to do is we're going to look at just part 1 and 2, and we're going to go through that together. Then afterwards, we're going to hit on just a little bit of each and then kind of go from there. First of all, I want to just mention that tomorrow's part is 15 questions, I believe. And though it might have different problems for each group there, about 15 problems is what the first part will be there. When you look at the first 15, the important thing to note is that you can't mess around. When you come in, I'm going to, in fact, allow people just to get started right away just so they have enough time there. So you need to be sure to be ready before you come into class. There will not be a whole lot of time for review. Now, with that being said, let's go over a couple things. First of all, you'll know that there are no review questions on here. That means that any of the review ones that we normally would have on this test are not there. If you're on my review, you'll notice the last 4 on that part, which is, I don't even remember the last 4, but the ones that were review we were going to hit on today, they're actually not on the test. So we're not going to focus on those today because we want to make sure we maximize the time on this review session. So again, I would like for you to still attempt them on the review, but at the same time, feel free to focus on other things going forward. Now, as we look at this, you're going to notice that a lot of this, like for instance at the beginning, graphing transformations is important. Next is find the domain of the graph. You're going to have to graph the transformation and find that domain. Also knowing what f minus g, f of g, and f of, f times g and f of g, what that means. A lot of times you'll see it as this, knowing that, you plug the g in for the x of the f of x equation. We'll do a couple of those a day. Also noting that after you solve for all of these up here, noting what that 2 means on the outside. That doesn't mean distributing. That means we plug 2 in for whatever our answer is in for x. A lot of times you'll see, well, we could just use this one, f of g of x, meaning that x is plugged in for x. Usually we don't do anything with that, but when we have a 2, we have a little different story there. And then finally, if I give you what h of x is, finding what f and g are to make up h of x is going to be very important. We'll look at that again, composition of functions, kind of breaking that down, kind of going backwards from what we did on number 3 here. And then finally, the big part on this is finding the inverse of different things. We'll look at that as well, and we'll discuss that going forward. Now, in part 2, you'll notice that this focuses on the circle and midpoint and distance formula, finding the domain of an equation. A little bit different. Up here it's you graph it first, then find the domain. Down here, it's find the domain from an equation given. That's a little bit of a review, but we'll hit on that again a little bit forward off that. And then finally, we're going to graph the inverse when given an equation as well. So again, that's kind of our parts there. We're going to look at that a little bit more in depth going forward. But before we do, what we're going to do is just going to go step by step through. Now, as we go through each part, notice, again, just a heads up, that if you were in my class, you'll notice these are a little different. Some of them may be related, but they are a little different. But don't worry about that. I'm giving you some different problems to focus on as we approach tomorrow's test. Now, again, this is on part 1. So again, we'll focus in on that and go forward. Now, anytime we have some transformations, a lot of people that I know really struggle when we have a number that's on the outside. Now, when given the horizontal and vertical transformation and even a reflection, such as this one right here with the -3, a lot of people don't struggle with that. It's more or less when we come and approach problems where we have that 2, a stretch or strain that's on the outside. So what we'd like to do is this. Let's start off by first noting that this 2, I am going to just put on the back burner. What I'd like to do is first start off with horizontal, then the vertical transformation. Note where we're beginning, then afterwards we kind of get an idea of what the graph will look like and then proceed forward, okay? So first off, I note what the parent function is. Because of these lines here, we know it's an absolute value giving us some sort of B figure. Whereas up here, because it's a square root, we know it's, I always call it the arrow, but it's going to be something that looks like this when it is positive. Now, as I look at number 2 here, well, number 2 that's on this one, I note that this is going to go right 2 and then up 3. So when I do that, I'm going to go right 2 and up 3, and I'm going to start off by putting my starting point right here. Now note that this is either the highest point or the lowest point. We call that either the max or min. You don't need to know that, but just so you're kind of aware of it there. Since this value on the outside, even though there's a 2 there, since it's positive, we know it's going to go in the upward direction. Now come over here for me. We know because this is on the inside, we think opposite. So this will be transformed to the left 4. Because it's on the outside, this is vertical. Whatever it says, that's what we do. So we're going to go left 4, down 2. So I'm going left 4, down 2, and I know that's where I start. Again, because this 2 is positive, it will be going in this positive direction. If it was negative, we know it would be going low, 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 apple bottom jeans, all right? Now, come back with me with the number 2, both of these, and note that since we have a 2 here and a 2 here, we know what the graph should somewhat look like. So with that in mind, we want to come up with some sort of T-chart that doesn't have a ton of values, but that just gives us a little bit more accurate of a reading going forward. Now, your teacher may have given you something a little bit easier to do, but I always find that the T-chart, it always helps us out in finding the most accurate values moving forward. So since we have our vertex here at 2, 3 for this one, I'd like to plug in, like, let's say a value at 3 and at 1. Okay, so let's plug in 3 first. And actually, I'll come back to 1 here in a second. So 3 minus 2 is 1. The absolute value of 1 is 1 still. It still remains positive. 1 times 2 is 2, and 2 plus 3 is 5. So when we go 3 to the right, we will go upwards to 5. Now, since we know this is an absolute value, you know that it will look something that looks like that there with our points. And since we know that it's going to go upward in the same direction, when I go up 2 over 1, we can assume that it does the same thing on the other side, up 2 over 1. And once I get that there, we know we can move forward. And so it'll look something like this. Shouldn't go down, should be there. Now, it did rise up, go 2 over, or up, rise up 2 to the right 1 and left 1. But we don't always assume that, because if it was x squared, we know that that wouldn't necessarily be correct. For instance, here, I can't just go up 2 over 1 each time. Because of the square root, we've got to figure out, is there something that I can plug in for x that would make this a little easier to solve? Well, I note if I plugged in 0 here, what would happen is I could take the square root of 4, which would be 2. Now remember, don't subtract 2 yet. We got to do PEMDAS. We do inside first, then outside. So 2 times 2 being 4, 4 minus 2 being 2. And so what I have is at 0, I would go up to 2. Now to be just a little more accurate, it's a little bit tougher than the one on the left-hand side here. what I'd like to do is just plug in a value that's a little bit more to the right that may be easier, again, helpful to solve for. For instance, if I plugged in, what value could I plug in for x that's a perfect square root or has a perfect square? We know that would be 5. So we'd have 2 times 5 plus 4, so it'd be 5 plus 4, minus 2. Again, we work inside to get the square root of 9. Don't distribute yet, because we know this would be 3. 2 times 3 is 6. 6 minus 2 being 4 there. And so because of that, I can go 5 to the right, and I can go upward to 4. Let's make sure we've got that there. So our graph should look something like that right there. It may not be completely accurate on this side, but that's pretty close for what we are looking for there, okay? Now note that this part here you will not have a calculator for this, okay? You will not have a calculator for this. If you want a 4-function calculator, you can do that. I would highly recommend that you bring one with you, because we don't know how many will actually be there for the test part. But again, just kind of giving you a heads up on that, you may want to bring in a calculator, 4-function calculator for the plugging in. But even these, you should be good to go on. They shouldn't be too rough there. Now let's look at the one that's down below on this one. We note that it's cubed, so we would normally think of it rising to the right like a half parabola up, and then also a half parabola down. So on number 4, we notice, again, the graph will look something like this. However, because this is negative, what would normally rise to the right would now, from the same spot, rise to the left and fall to the right in some way. So really we're looking at the green one because of that reflection there. Now, because of the x plus 4, we know we're going to transform left 4. And because of the positive 1, we're going to go up 1. So our starting point no longer is at the origin. Now it's left 4, up 1 because of the horizontal and the vertical transformation. Now, as I look at this, I go left 4, up 1. Because of the negative 3, I again want to create a graph that when I end up creating that t-chart on it, we have some values that we could plug into the right and to the left from that starting point. I always go, like, let's say, I always go to the right one. So let's plug in negative 3, and let's just see what happens. So I have negative 3 times negative 3 plus 4 cubed with plus 1 on the outside. So I have 1 in here, cubed, 1 cubed. Remember, I work inside out, right? Okay, remember, don't multiply these two, right? Let's make sure we do the order of operation. 1 cubed is 1. Times negative 3 first is negative 3 plus 1 is negative 2. So what I have now is at negative 3, I'm going down to negative 2. And since I know that, again, just like with this graph, this would release downward somewhere through there. So it went right 1, down 3. This one is going to go left 1, up 3. It's going to have to, because again, we know what the parent function looks like. You could also plug in negative 5 here. And when you do, you know you will go up to positive 4, okay? So again, that would work there by plugging in another value, but if you know your parent function, that will help you to determine if I go right 1, down 3, on the other side I have to go left 1, up 3, because we know that it's a negative reflection there. So the big thing to note is like cube, rise right, fall left. Something that's squared is a parabola. Something with absolute value is a v, right? Square root of x is something that looks like so. And so all of those parent functions are important, especially as we transition for tomorrow's part of the test. Okay. Now the next part, I will be honest, this next part is not, it's a little more tricky than the actual test is. But I'll tell you that if you can actually figure this part out, that you'll be G to G for tomorrow, okay? So let's do this. Remember F plus G. I'll just kind of walk through this with you briefly. Remember, this X does not mean that we distribute X once we're done. It means that X is plugged in for X, which if you plug X in for X, whatever you get at the end is what you get. So in this example, we get X squared plus 2X plus 3 plus X squared minus 3, because we know we've got the F part plus the G part. We simply combine like terms to get 2x squared plus 2x. because the 3's would cancel, all right? Now with the f minus g, a lot of things that I see with my class is just kind of dumb little mistakes where we take the f and we subtract the g, but for some reason we only keep the negative with the x squared, but remember it's got to distribute to both. So this should now be negative x squared plus 3. This is gone now, right? And now I combine like terms. So x squareds are gone, leaving me with 2x plus 6. Okay, 2x plus 6. And again, I'm going through those quickly because I know we should be okay on that. All right. Oh, yes. Hold on. Time out. I'm coming back to number 9. Hold on real quick. Remember with the domain here, come back to number 4 if you did that work. The furthest left would be negative infinity. The furthest right would be positive infinity. We'll put it in interval notation so my domain is negative infinity to positive infinity. On these previous ones, the furthest left on this one would be negative infinity. Furthest right would be positive infinity. There's my domain. Now with this one, the furthest left I go is negative 4. Again, we'll use a bracket because it actually hits that spot. And the furthest right I would go is positive infinity. So just an idea, again, you'll have something that looks very similar to that where you have to find the domain on the test. So just be leery of that there. Okay? Apologize for that. We'll keep it going here. F times g is one where we have x squared plus 2x plus 3 multiplied by x squared minus 3 here. Again, very similarly, don't just multiply the first and the last ones. You've got to distribute. X squared times x squared is x to the 4th. X squared times negative 3 is negative 3x squared. Now we go to 2x. 2x times x squared is 2x cubed. 2x times negative 3 is negative 6x. 3 times x squared is 3x squared. And 3 times negative 3 is negative 9. So what we have now is x to the 4th. Okay, so that's gone. 2x cubed, that's there. Negative 3x squared plus 3x squared would be gone because those cancel out. Okay, these are gone. Negative 6x stands alone, and then minus 9. So that's what you should get when you distribute out. Just be careful. Make sure you distribute those values there. Okay, and remember, when I have x squared times x squared, okay, that equals x to the 4th. Just little stupid things there. It's because we add those exponents, not because we multiply. We add those exponents together, okay? For instance, x to the 3rd times x squared would be x to the 5th. Just be careful on that. Now, f over g is where we would have x squared plus 2x plus 3 all over x squared minus 3. In this example, I can't do anything with that. Do not, okay? I will haunt you and your children's children. You cannot cancel here. No, okay? Do not do that. What you have to do, okay, backtrack there, is I've got to factor the top here. But there's nothing that multiplies to 3 that adds to be equal to 2. So, and down below, I can't factor that as well. So I'm going to leave that as is right there. Just leave it as is. Now, with the composition of functions, this is where we, again, maybe you had some trouble with this, maybe not, but this is where we plug g in for f, right? The second one goes in for the first one, so it's going to be plugged in for x. Since there's 2 parts within f of x, it should look like this. It should be x squared minus 3, okay? But remember, it's squared, right? So we keep that squared on top. Plus 2 times x squared minus 3, right? Plus 3 on the outside. So that right there is our equation, so to speak, when I plug in g in for f. So what I would do is I would square here. So don't just square both parts. You're going to actually have to distribute x squared minus 3 times x squared minus 3. And then I'm going to have to distribute 2 here to 2x squared minus 6. And then keep that plus 3 on the outside. So right here, this would be x to the 4th minus 3x squared plus 9, and then include all this stuff to add together and go forward, okay? The next one is one that I really want to focus on. It's the G composition, or the G of F, where we're doing the composition here. This is where the F goes in for the X of G. So this one would be x squared plus 2x plus 3, all squared, and then minus 3 on the outside. okay? Now, let's do this. Let me backtrack for a second. Since we're changing this up, let's pretend that f of x is not this. Let's pretend that f of x is equal to 2x minus 3, and g of x is equal to x minus 4. If I did the same thing, I'm crossing this out for a second. If I did the same thing, the f would go in for the x of the g. So what I would have is now 2x minus 3, I substituted in for x, minus 4 on the outside. So since there's nothing that's distributed, now if there was a 3 here, I would distribute this 3 across. But since there's not, I'd have 2x minus 3 minus 4, leaving me with 2x minus 7. Now, what would happen if instead of g of f, I would have g of f, same thing, except with the 2 here. This was on one of the concept lists we talked about. The 2 then would be plugged in for the x. So it would be 2 times 2 minus 7, which would be 4 minus 7, which would equal negative 3. And so just a heads up, if I'm putting that 2 on the outside, no longer do I keep it as 2x minus 7, but I put 2 in for wherever I see the x value there, right? Here's a good example of it. Let's look at this one, number 16, and let's look at number 14. In fact, actually, before I do that, I want to do this one first. Let's do these 3, and then I'll come down to these 2. If I have g to the negative first, what that represents is we want to solve for what the inverse is. A lot of times I'll put in y just so that I know kind of what I'm doing there, but it's really g of x just tells me it's a function. So what I'm going to do is I'm going to switch x and y, and now I'm going to solve for the new y here. Solve for the new y. So what I'm going to do now is I'm going to break this down. So I can't divide by 2 yet, but I can add 3 to either side. So I have x plus 3 equals 2y. Again, my goal is to get y by itself, so I'm going to divide all of this by 2, giving me x plus 3 all over 2 equals y inverse. Or since we're talking about g, it would be g inverse there, okay? So that's what we're talking about on that one. Now, one like 14 is where we're going to plug 2x minus 3 in for x, just like we did earlier, okay? So we'll have 2x minus 3 squared plus 2 times 2x minus 3 and plus 3 on the outside. So again, we can distribute, we can do all that. However, since we know that x is not here and we know 3 is plugged in for wherever I see x, that's where I plug 3 in. Let's just plug it in. So we have 2 times 3 minus 3 squared plus 2 times 2 times 3, again, minus 3, and then plus 3 on the outside. So let's work inside out. Let's go parentheses first. So we have 6 minus 3. That's going to be squared plus 2 times, again, inside the parentheses first, 6 minus 3, and plus 3 on the outside. So now let's keep going. I have 3 squared, which will give me 9, plus 3 times 2, which gets me 6, plus 3 on the outside. So 9 plus 6 plus 3 gets me 18. My answer would be 18 for that specific answer there, for that part, okay? Similar to what we did previously here. I don't think I kept that one last time, but you're going to plug in this part in for the x right here. And then once you're done, you input 1 in for wherever you see x on that side, okay? I don't think this is on the test, but just in case it is, if I do g of g, that means 2x minus 3 is getting put into itself. So the g is in for g. So this is going to go in for the x part. So I'd have 2 times 2x minus 3 on the outside. So distribute 2 to get me 4x minus 6. Remember, distribute 2 to both. And minus 3, so I have 4x minus 9. Noting the fact that this has a 3 here, we plug 3 in for x to get me 12 minus 9, and that equals 3 there. So when I have like g of x, what that means is x goes in for it, so there's my answer. But if I ended up having a 3 on the outside, I put 3 in for x to get me what my ultimate answer is there, okay? All right. Again, hopefully this is helping you out here. Let's do the next part, which is the composition of functions here, where we have f of x and g of x here, okay? In this example, the g, again, we're trying to find something where the g, or this part, is plugged in for f of x. I always say this, if we're trying to get, like this is our answer, right? Before we were trying to find our answer. This right here is our answer. We're trying to find two functions that when g is plugged in for f, we get a result of what you see with h of x here. I think this one was on both reviews here. I think I remember that. So in this example, I always say that the junk on the inside, and by the way, there's multiple answers with this, but the junk on the inside, let's take out. So that's like the x squared plus 5x plus 4, okay? So if I take that out, what's left over? Well, I have two absolute value, right? Because it's taken out. Well, whatever you take it out for, we just input it with an x, okay? All right? So what we could say is if we take the junk and plug it in for the x inside, we will get back to where we were originally. Well, remember that whatever's being plugged in, that's the g of x. So the g of x would be x squared plus 5x plus 4. And whatever was like the standard part of it would be two absolute value of x. So you could test it. If you took g and plugged it in for f, you should get back to this part of the answer, and we actually did. Try out this next one. See if you could figure this one out. If you need to pause it, you can. Again, the same thing occurs. Okay, I take out the junk. Now the junk could be a bunch of different things. You could make it x minus 3 squared. You could just, I like to take out the inside. So I want to take out x minus 3. And when I do, I have squared minus 1. And remember, wherever you took that out from, you put an x there. So the junk would be the g of x, x minus 3. And the rest of this, the part that's left over, would be the x squared minus 1. So I could plug x minus 3 in for x to get me back to 18. And so that right there would be my answer on that. Okay? Perfect. All right. Keep going with me for a second. All of the rest of this stuff that you see is stuff that will be on part 2. We're going to hit on that in just a second. But before I hit on any of those parts, what I'd like to do is go back to some of these inverses and see if we can solve for a couple more of these and see if you can, again, figure this out, okay? 3x minus 1. And let's do another one. Let's do h of x equals 2x squared minus 3, okay? All right, so let's do these two. And again, if I say h negative 1, what that means is h inverse, okay? That's what we're trying to look for. And same with g inverse. We're trying to look for that. Okay, so let me do this one in yellow. We'll do this. We'll say y equals 1 over 3x minus 1. Okay, so what we got to do is flip x and y first, okay? So I'm going to actually, for sake of room, I'm going to pull it over here. So let's go x equals 1 over 3y minus 1. Now, one thing that I like to do is I do not like this y on the bottom. And I'll be honest, this one's probably one of the more difficult ones on the test. In order to get that y to where I could work with it, I like to flip this because I know I want to get y by itself. But if I were to flip it, I've also got to flip x and 1. So this whole thing would end up equaling, if this, hopefully this will make sense to where we're going. But what I'd like to do is flip this to where now it's 1 over x equals 3y minus 1 over 1. And obviously we could keep that as is. Now, how do I get y by itself? Well, I can add 1 to both sides, right? And again, this y1 should be to the whole thing. So it should have 1 over x plus 1 equals 3y. Now, how do I get rid of this 3? I can divide by 3, but if I do, I'm going to end up having something that looks like this, which can be kind of confusing. So instead of dividing by 3, which you could do, it still could work, I'd like to multiply by 1/3. Well, if I do it to this side, again, same thing, I've got to do it to this side as well. So I'm going to multiply this by 1/3 as well as this by 1/3. So what I have now is 1 over 3x plus 1 over 3 equals y. And really it's y inverse. And since we're talking g, we could talk g inverse now because we can come back to where we were at. Now, in order to get this really, really good, I want a common denominator. So this is 1 over 3x, 1 over 3. So if I add an x here, I can add an x on top. So this is really 1 plus x all over 3x equals g inverse. And so that right there is the complete correct answer there. Now within this one, again, y equals 2x squared minus 3. We switch x and y. This one's, I think, a little easier, but I don't know. Again, don't divide by 2 here because we want to get rid of that 3. Our goal is to get that y by itself. So we have x plus 3 equals 2y squared. Divide by 2, divide by 2. X plus 3 over 2 equals y squared. Okay, we like to square root this, square root both sides, to where now I get the square root of x plus 3 over 2 equals h inverse, okay? Now there's something that I messed up on. Whenever I square root a squared, the important thing to note is I need to make sure I have a plus or minus there. Okay, got to have a plus or minus on that. So square root a squared, just kind of give your heads up on that. Plus or minus, again, that would be like a -1 point on the test, but I want you to get all the points you possibly can. Again, this is not on anyone's review, but very, 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 very important. And there are 4 types of problems like this. One like this, one similar to these two, and one that's a little different. But if you understand the concept, you should be good to go off that, all right? All right, now let's go over this. And again, we're going to wrap this up here because I know I've got some stuff to get to. I'm going to go through this very quickly, so please fasten your seatbelts. If you need more help on this, this is now part 2 we are moving into now. Part 2 of the test now moving into on this section. All right, here we go. If I have something that is in the bottom of a denominator or bottom of a fraction, I know I need to set only the bottom equal to 0, right? Because x can't be equal to whatever makes the bottom equal to 0. We call that undefined. So when we do this, and it wants it in interval notation, this is very important. If you've been in my class, I've allowed you to do it either way. Today, I'd really like for you to focus on this part right here, okay? So really focus in on this. So right now, x squared minus 25, we could factor to x plus 5, x minus 5. A lot of you know how to do that. Now, if I set both of these equal to 0, we know that x cannot be equal to -5 and 5. Now, since we know this is the case, this is true, this is completely true, but to get the full points on the test, you've got to note that from -infinity to -5, that's part of it. Then from -5 to 5, right? Again, remember no brackets because it can't be equal to that. Can go to it, but not be equal to. And 5 to infinity. And remember, we'll put the union symbol there. That means all of these values, got the range, or the domain rather, has to fall in between these 3. Now remember, within a square root, the 3x plus 12 must be set greater than or equal to 0. So I'm going to subtract 12 to where 3x is greater than or equal to -12. If I divide by a negative, remember, we got to flip it, okay? So just remember that. But then now once we divide by 3, x is now greater than or equal to -4. Well, if it's greater than or equal to, we know from -4 to infinity, where, again, it's equal to, so we'll allow that to be a bracket there. That right there would be my domain for this value here, for this function. Now, if it doesn't have something in the denominator and it's not in the square root, then we know that if there's nothing, whoa, that was, whew, that was, I'm sorry, that was disgusting. Oh, I'm trying to go so quick. All right, so if it's at the bottom or if it's in a square root, we know that in that case, we know the domain would be from -infinity to +infinity. It could be your mama in here. It does not matter. As long as it's not in the denominator or in a square root, there are no restrictions to where the domain can be. So it's from -infinity to +infinity. I hope you're experiencing this quick because we're going to rock and roll. Now, within our circle, the transformation within the inside, just like beforehand, this is opposite. So we got to think that this circle has a center at 2, -3. So my center's at 2, -3. Again, that's a point, 2, -3. So about right in there. Since I know my radius is not 16, the radius is the square root of 16, because remember, it's x minus h squared plus y minus k squared equals r squared. So because that r squared is there, we set this equal to r squared to where the radius would be 4. So we go up 4, right 4, and it might not be perfect because it's harder to see, but you get the idea to where this circle should have a radius of 4 with the center at 2, -3. All right, keep going with me. Now, if we're trying to find the standard equation of a circle, we know that -1 and 5 represent h and k. So this should be x minus -1 squared plus y minus 5 squared equals, remember, 4 squared. So this is equal to 16. Y minus 5 squared. This is going to be x plus 1 squared. And once I have that there it is. There's our standard form of our equation. Remember, this would be, our center would be going to the left 1, down 5, with our radius at 4. So just remember this equation, know how to manipulate with that, all right? Now the next one of the tougher problems here, we want to group x's together, okay? Group the y's together. Now, once I get to this point, we also want to get rid of this -23 by adding it to the other side. Now, understand, when we do this, just like we did beforehand, we want perfect squares, okay? Perfect squares. These squares are huge, okay? So in order to get perfect squares, we take the middle value, come over here for us, we half it and square it. So half 4, we get 2. Square the 2, we get 4. If I add 4 there, I've got to add 4 to the other side, got to give some love to the right side. And for this one, if I half -6, I get -3, and square -3, I get 9. So if I add 9 here, I add 9 here. So once I get to that, I get 23 plus 4 plus 9, which gets me a total of 36, okay? So once I say this, what two values when multiplied get me 4, but when added get me 4? We know that would be 2 and 2. It should be a perfect square. If it is not, you got to go back, okay? Got to go back, did something wrong. Two numbers that multiply that equal 9, add to be equal to -6. That'd be -3 and -3. So since they're perfect squares, we could come down here, and keep that plus in the middle, to get x plus 2 squared plus y minus 3 squared equals 36. My radius, remember, is whatever's on the outside square rooted. So radius is 6, and my center would be -2, 3. Okay? That right there is my center. And hopefully you know how to graph it based off of 22. If you need some help on that, we might need to look at that before Tuesday on part 2 there. All right. You all are awesome. Let's do this. Let's finish off with this last one, and we'll go from there, okay? Remember when we find square root of 5, if we were to do that radius, remember we take the square root of 5 and square it, and which would be 5, right? So this would be equal to 5. So you have all your other stuff for your center, or for your circle, but the radius, square root of 5, we'd square it to equal 5 for that form there. All right, last but not least, let's look at number 27 and 28. Midpoint formula, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. x1 being 2, x2 being -5, so 2 plus -5, all over 2. So 2 plus -5 is the same as saying 2 minus 5, which is -3. So it's -3 halves for my x is my midpoint there. Y1 plus y2 would be 5 plus 7 divided by 2. So that's 12 divided by 2, which is 6. My midpoint would be -3 halves, comma, 6 there, okay? So that's our midpoint. Remember our midpoint formula on that, okay? Distance, okay, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. We know that x2, we can make x2 either way, just make sure we're consistent. So we'll say 1 minus, I'm sorry, that's the y, I'm sorry. 6 squared of 2 minus 3 squared of 2. So let's take it step by step. 6 squared of 2 minus 3 squares of 2. Then we'll square it. Again, I'm going to take this one a little slower here. I'm going to slow my mouth down. This one, since this was x2, this is y2 here. So 1 minus 5. Okay, we'll square that. All right, so we got our distance. Okay, got our distance here. So let's go inside. Remember, well, we know 1 minus 5, that's -4. We're going to square that in here in a second, okay? 6 squared of 2 minus 3 square roots of 2, we don't do anything to the square root of 2. Because it's like terms, we can't do it unless it has the same root. Since it has the same root, we can just say 6 minus 3, which would be 3, and we keep the square root of 2 there. Again, still all underneath, that square root. We work inside out, so we square 3 squared root of 2. Okay? 3 squared root of 2 times 3 squared root of 2. We multiply the outsides together to get me 9, and multiply the insides together to get me square root of 4. Well, the square root of 4 being 2, 9 times 2 gets me 18. So really, we have 18 for this part right here. On the inside, because this is in parentheses, we say negative 4 squared would be 16. Therefore, we add 16 and 18 together to equal a total of 34. Remember, we're still in a square root. So now this is where we can use our calculator for this part. And by the way, part 2, you can use your TI calculator for the test. I have no problem with that. And really, to be honest, both parts, you really don't need your calculator at all, not even a 4 function, but I'll allow you to use the 4 function if you need to. The square root of 34, we want to round it to 2 decimal places, would be approximately 5.83 as our distance there. So the distance between point 1 and point 2 is 5.83 or square root of 34. Again, 5.83 is what we're really looking for. All right. Now, to finally finish up on this last problem, 2, 4. Okay, I'm going to redraw this here. Actually, you know what we're going to do? We're going to throw that out. I want to come and I'm going to redraw it on this, okay, so that it's a little easier. So I'm not going to worry about this. The big thing to note is what are the points for the blue? The points for the blue is 0, 0, 2, 4, and negative 3, negative 1. Okay. Now, in order to find what the inverse is, we'll do this in red. Okay, so f negative 1, again, reminds me that I'm doing the inverse of this graph. Well, to do that, remember we switched x and y. If you can remember with me, on the ones we did earlier over here, whenever I found the inverse of something, both for part 1 and part 2 of those, and even the third one, in order to do that, we switched x and y and we solved for the new y. Well, coming back over here, remember, you don't have to actually draw this, but remember it's reflective over the y equals x line. That's what an inverse is. It's reflective over that line. So to do this, we got to switch x and y. Well, if I switch 0, 0, I just get 0, 0. We can do that. Switch 2, 4, we get 4, 2. If we switch negative 3, negative 1, we get negative 1, negative 3. And then what we're going to do is graph this. So we have 0, 0, 4, 2, and negative 1, negative 3. So what we have now is our graph that should be, and it should be there, I'm sorry, it should be a little higher. But it should be just like that. That is our F inverse equation based on what was given to us here. So we find our points, we switch x and y, very similar to what we did previously. Again, that will be on part 2 moving forward on that, okay? Hey, again, I know we did this very quickly. I went through most of the review there. I hope that was helpful for you. Happy Easter to y'all. Again, I'll kind of post this here if you needed to take something with this. Notice that, again, I did make a mark here on the first part and in the second part. I went through all different types of ones that will be on the test. The big thing is this: what are you going to do from this Easter going forward on both parts? Again, I see a lot of people, man, they focus on that first part and maybe they don't do very well on the second part. Whatever you need to do, maybe right now, even as I'm talking, maybe you're focused on that first part, but maybe that second part you wait till Monday night to focus in on. Maybe you really work on the first one, then go to the second one. Again, the review will be due Tuesday. However, I would really hone in on those parts that are on the review that you'll really need for that part 1 on Monday. Hey, I love you all so much. I apologize this is not live. However, I think this will be really helpful for you as you prepare for your tests. Again, if you have any pressing questions on that, you can text me or email me. Be more than happy to get with you as soon as possible. Even though I have things going on, I will have my phone on me to where I can answer questions there. Anyway, I think this podcast was pretty extensive. I love you all very much. Have a great day. Happy studying. And let's tear this test up right before spring break. All right. See you.